Good morning, everyone, and thank you for joining us. My name is Dave Newman, and with me as our producer is Adam Schretzel. Today, we're going to be covering several very important topics: leak check versus pressure test, and we're also going to do a demonstration of flow and lockup, how to perform these tasks, and why they're so important. Adam and I have been in the propane industry for a combined nearly 50 years. We are both training coordinators for FWeb's gas division. FWeb is a 150-year-old family-owned and run business with 15 different disciplines, plus engineering. So we're happy to be here, and thanks for joining us. The topics we're going to cover today are: what is a pressure test? What is a leak check? When do you perform each? What are the numbers we're looking for? What is flow and lockup? We'll also address regulator creeping and how all of the above affect the technician, the homeowner, and your company. We're going to start with a small video from PERC, Propane Education and Research Council, which, just to let you know, you have great assets within these organizations, PERC, as well as others we'll talk about shortly.
Of conducting a pressure test is to make sure the interior gas piping holds pressure while being subjected to an elevated pressure. The test is performed downstream from the point of delivery and prior to appliances being attached to the system. Typically, a gauge is connected to the interior piping stub-out location. The test must be performed using air or an gas to pressurize the system and then monitoring the pressure with the gauge. If a gas shutoff valve is installed and subjected to the pressure, be sure it's rated for the pressure being applied to it. After a successful pressure test is completed on a new gas piping system, a leak check is required at the time propane is introduced into the piping system. A system leak check is necessary to make sure the gas system is free of leaks. Here, the technician is using a water manometer to conduct the leak check. However, there are other devices as well, such as the magnehelic pressure gauge shown in use at the water heater. Before a leak check is performed, the appliances need to be connected to the gas piping system. The regulators need to be installed, and the gas piping needs to be connected to the propane container. Be sure to follow code requirements and your company policy when conducting a leak check. If a leak is indicated by a drop of pressure during the leak check, a leak test is performed by applying a leak detection solution to the pipe fittings and connection points of the gas system. A leak detection solution will bubble to indicate the presence of a gas leak in the system. An electronic leak detector can also be used to detect leaks. Never perform a leak test with an open flame source. After a leak is repaired, another leak check of the gas piping system is performed to verify the rest of the system is free of leaks. After the leak check is complete and the gas piping system has been purged, the appliance is ready to start up. The service tech is able to perform gas piping system flow and lockup tests with the same manometer position. Flow and lockup tests are typically performed on gas piping systems during startup to determine if the gas piping system and regulator are sized correctly for the intended BTU load, and that the regulator properly stops the flow of gas when there's no more demand on the appliance. In this example, the appliance inlet flow pressure is too low, as the furnace manufacturer, in this case, requires a minimum of 11 inches of water column pressure at the inlet. When the pressure is too low under flow conditions, the technician will check the pressure at the second stage regulator, usually mounted at the exterior building wall. Here, the service tech is using a manometer at the second stage regulator outlet to perform the flow pressure test on the interior portion of the gas piping system to verify a possible issue with improper interior gas pipe sizing, indicated by failed flow and lockup tests at the furnace. In this example, the manometer check at the second stage regulator indicates it's supplying 11 inches water column to the building piping. Considering that 11 inches water column is normal pressure and the pressure is much lower at the appliance, a possible interior pipe sizing issue is indicated. All system checks and tests should be documented according to your company policy.
That's a great video. And again, that is available to all of you who are NPGA members. As you can see, there's a number of different resources for you, including www.propane.com, propane101.com, NPGA, as well as other tools. So please don't hesitate to utilize those for something as simple as a safety meeting. So again, those are all available to you. Also, what we're deriving our information from is both NFPA 54 and NFPA 58. First thing we're going to talk about is a pressure test. NFPA 58, by definition, describes that as an operation performed to verify the gas tight integrity of a gas piping system following its installation and or modifications. In 6.13.3, it states that piping within the scope of NFPA 54, or in the doors, we say, shall be pressure tested in accordance with that code. So make sure you're following each code, 54 and 58. And 54 is very specific when it comes to pressure test. In leak detection from NFPA 54, Chapter 8, we have to keep in mind they're very specific about what we can use for our test medium. The test medium shall be air, nitrogen, carbon dioxide, or an inert gas. Never use oxygen for this test. 8.1.4.2 tells us that the test pressure to be used shall be no less than 1.5 times the maximum allowable working pressure, but no less than 3 psi, irrespective of design pressure. So even if you have a low pressure system working at 11 inches of water column, NFPA 54 tells us you must use no less than 3 psi. The test duration is also addressed in 54, and that shall not be less than a half hour for each 500 feet of pipe volume or fraction thereof. But they make an exception when testing a system of less than 10 feet or a system in a single family dwelling. The test duration shall be a minimum of 10 minutes. And the duration of the test shall not be required to be more than 24 hours. That being said, if you do a gas piping system and you put a pressure test on a nice fall afternoon at 80 degrees Fahrenheit, and the inspector can't be there till first thing in the morning, know that if you're using air, you may find a pressure drop. There is a formula in the annex of NFPA 54, which can help you document that due to the loss in temperature, we've lost some pressure. So just keep that in mind. Be familiar with your code books, 54 and 58. A leak check by NFPA 54 in Chapter 8 says that is required immediately after gas is turned on into a new system or into a system that has been initially restored after an interruption of service. Piping systems shall be checked for leakage. Where leakages indicate, the gas supply should be shut off until the necessary repairs have been made, and then you must leak check again. So what is an interruption of service? It could be a number of different things. Of course, a runout. If a customer loses pressure in the propane tank and they call you for a delivery, that is a runout and a leak check is required. To protect yourselves, your company, document your leak checks, as well as pressure tests for that matter. Another interruption of service would be, for instance, if a seasonal home, the homeowners decide that they don't need their gas on while they're away and they shut it off. That does require a leak check. So somehow you've got to let your customers know that that is required. Shown here are a number of different leak check and pressure test pieces of equipment. The first on the left is the same gauge setup that they used in that PERC video. It's great. You can, as they showed in the video, you can charge the system for the pressure test with air. You saw they just had a can of air. You could also use nitrogen, that bottle in the center. And we also carry the regulator required for that nitrogen bottle. Here shows a number of different leak check and pressure test pieces of equipment. It's highly recommended that your technicians have some of these things. A simple, on the first one on the left is a simple low pressure gauge, reads up to 30 inches of water column. There's a couple of them there. On the bottom left is what we call a serviceman's friend. It's a great, inexpensive tool, and that's going to help your technician or driver tie into the system in a number of different places. Right in the center, those yellow pieces of equipment are digital manometers. Those are great, but keep in mind they do have to be checked for accuracy occasionally. So keep that in mind and read the instruction manual from the manufacturer as to the intervals. The YouTube manometers are a great tool, and they don't lie. Unlike the gauges and the digital manometer that have to be checked occasionally, these YouTube manometers, as long as you zero that manometer, it is an excellent tool. And FW Web carries every one of these pieces of equipment and others. On this slide, it shows a number of different ways to tie into the system. The left side are Presto Tap pigtails. Rather than disconnecting your pigtail every time you have to do a leak check, and you have the opportunity to flake off some copper within that pigtail, you can use a Presto Tap pigtail. So no disconnecting of the pigtail, you just tie your test equipment to the small adapter that's on the pigtail. In the center is a Presto Tap Unitech kit. We call it a Universal Gas Diagnostic and Leak Kit. This comes with a whip. It comes with 4 different gauges, a 300-pound gauge, a 30-pound gauge, 5-pound gauge, as well as an inches of water column gauge. It's great for a technician. They really come in handy, and again, you can tie into the system anywhere you'd like. And the others are just some other tools that are available to you folks for your drivers and or techs. A must-have on a service truck or delivery truck is a leak detection solution. These leak detection solutions are non-corrosive, which is very important. Do not be tempted to use anything else. Any cleaning agents have chlorides that can deteriorate the pipe or tubing, so make sure you're using non-corrosive leak detection solution. And you can use either the brush type bottle or a spray bottle. These are a number of different gas sniffers. We have these available. They're a very handy tool to find that leak. If you're doing your leak check and you find that there is a leak, these will really help you locate that leak, repair it, and then again, test that system. Very important. And document. This Regal LP Gas Serviceman's Manual is a great tool. In it, besides line sizing charts, there are descriptions of how to do proper line sizing using the longest length full load method. There is also excerpts from NFPA 54 and 58 on how to perform a proper leak check at different parts of the system. So it's a great tool. And if that's something anybody needs, please contact your local FW Web and we can provide them for you. So I'm going to read, and these come from the annex of NFPA 54, leak testing the installation. And we'll start with the low pressure testing procedure or the manometer method. We're going to use a low pressure test gauge, inches of water column, or a YouTube water manometer. We're going to inspect all the connections and appliance valves to make sure such connections are wrench tight, that all appliance connections are closed, including pilot valves, and all line shutoff valves. You're going to connect your low pressure test gauge or manometer to a range top burner orifice. For instance, if a range is not available, a special T may be installed between the appliance shutoff and the inlet to the appliance. Several shutoff valves have a pressure tap port that may be used also. Open container valve to pressurize the piping system. Leave it open for 2 or 3 seconds to make sure the system is fully charged, and then close tightly. They ask you in this to return to the appliances and open each appliance piping shutoff valve slowly. If the pressure drops below 10 inches of water column, repeat this. Observe the indicated pressure on the low pressure test set of the manometer. This reading should be at least 11 inches of water column. Now what you want to do is slowly open one burner valve in appliance or create a small leak or bleed through a pilot valve enough to reduce the gas pressure to 9 inches of water column plus or minus. If you find over a 3-minute time, a constant pressure indicates a leak tight system. A drop in pressure indicates a leak in the system. If that does occur, check the joints and other possible points of leakage with an approved combustible gas detector or our non-corrosive leak detection solution. Be sure, if you're tempted to use soap and water, you clean that piping anywhere that you sprayed it. But in my opinion, use the proper stuff and it's not going to hurt your piping. So if the pressure dropped, you have a leak, you locate it, fix it, and recheck it. Leak check. If there's an increase in pressure, it indicates that the container valve is not completely shut off. Shut off the container valve tightly and repeat this leak check. If you continue to see a rise in pressure, use your company policy for repairing that service valve or changing out the tank. Another way to leak check the installation is the high pressure testing procedure. Inspect all connections and appliances as we did before, then install a high pressure test gauge adapter on the tank service valve and connect the other end of the gauge adapter to the pigtail. A lot of newer tanks do have a test port in the service valve, so please feel free to use that rather than disconnecting and reconnecting your pigtail. Open the container valve to allow the system to pressurize while observing the indicated pressure on the 300-pound test gauge. Close the service valve tightly. Note and document the pressure reading on the pressure gauge. And then slowly bleed gas between the service valve and the gauge adapter and reduce that tank pressure by 10 psi. Again, document. Note that reading on the gauge. If the gauge reading remains constant for 3 minutes, it can be assumed that the system is leak tight. If the pressure reading drops, it indicates a leak somewhere in the high or low pressure piping system. Just a note that a pressure drop of 15 psi in 10 minutes may indicate a leak as little as 10 BTUs per hour. Check your joints and other possible points of leakage with an approved combustible gas detector. Soap and water, again, I'd prefer your non-corrosive leak detection solution or an equivalent non-flammable solution. Do not ever check for leaks with an open flame. Again, if you notice an increase in pressure, again, you're going to find that the service valve is not closing completely. So you must address that. If there's an increase in pressure, as I just noted, it indicates the container valve is not shut off completely, and you can address that with your own company policies. Disconnect the test gauge adapter from the service valve, reconnect the pigtail, tighten, and test that connection with your non-corrosive leak detection solution. If required, you may want to proceed with the manometer method that we spoke of earlier. This slide represents or talks about the high pressure test method with the service valves equipped with a pressure test port. Again, inspect all connections and appliance valves to be sure connections are wrench tight, that all appliance valves are closed, including pilot valves. Install your pressure test gauge on the test port downstream of the tank service valve seat and upstream of the pigtail and regulator inlet. Open the container valve to allow the system to pressurize, observing the gauge reading on the 300-pound gauge. Close the service valve tightly. Note the pressure reading on the pressure gauge. And then, again, as we said before, slowly bleed out 10 psi off that tank pressure. Retighten the gauge adapter into the service valve or close the bleeder port. Note the reading and document it. If gauge reading remains constant for 3 minutes, it can be assumed the system is leak tight. And just as our last high pressure method, we're going to follow the same rules. Check the joints and other possible points of leakage with an approved combustible leak detector, non-corrosive leak detection solution. Never test with open flame. Just as in the other tests, if there's an increase in pressure, it indicates the container valve is not shut off completely. Shut the container valve slightly and repeat. Now disconnect the test gauge from the service shutoff valve or leave it in place if desired. If the gauge is removed, plug the opening and check it for leaks. If I hadn't mentioned before, please feel free to add into the chat room, and we will be answering questions at the end of this. So now we're going to talk about regulated delivery pressure and regulated lockup. Check the regulated delivery pressure per 54 with approximately half the total appliance load in use. Your gauge should read 11 inches of water column at the appliance. Adjust the regulator if necessary. However, keep in mind when you make an adjustment to a regulator, you're going to adjust its lockup pressure as well. And we're going to get to lockup here shortly. So adjust the regulator if necessary, and do that slowly. Following this, turn on all appliances to make sure that the pressure is maintained at full load. And if excessive pressure drop occurs, inspect your piping for kinks, flats, or other restrictions. But appliance regulators or gas valves are installed in most appliances and may be preset by the manufacturer for flow pressure lower than 11 inches. It's recommended that the manometer test or test gauge be installed at a location other than a range orifice or appliance pressure tap when performing lockup and delivery pressures. So keep that in mind. Do this test before the gas valve on the appliance. Regulator lockup and leakage. After this, shut off all the appliance valves to determine if the regulator has a worn seat or if it has been set too high to compensate for line losses due to undersized piping. Again, if you adjust the outlet pressure of a regulator, you're ultimately adjusting the lockup pressure as well. A slight rise in pressure will occur during these conditions, and that's normal. That's called lockup, and that is the regulator closing. The lockup pressure should not exceed 130% of the regulator's set delivery pressure. A quick rise in pressure above this point will indicate undersized piping. And shortly, we're going to show you what we mean by this with a couple of examples. Continue this lockup test for 5 minutes or more. If a creeping rise is noticed in the pressure, the regulator seat is not closing off properly. Inspect the regulator inlet nozzle or orifice for dirt, scratches, or dents, and seat discs for sign of wear. Replace where necessary. For more information, refer to NFPA 54, the section on inspection, testing, and purging. NPGA Propane Safety and Technical Support Manual Bulletin 403. And in pressure testing and leak checking LP gas systems. What they're referring to with the creeping rise oftentimes means there may be something stuck in the regulator, whether it be pipe thread shaving or a shaving from underground yellow gas pipe. So make sure your piping is clean before you install and start inspecting. Some things we're going to discuss. How can what we have discussed today affect you? How about your customer? How about the company you work for? What we've discussed really is all about safety and protecting yourself. In the event there happens to be an accident at a particular home or business, you performing these tests and checks properly and documenting them can protect you. And it's very important that we protect our customer as well. We're about to show you a video that's going to describe, we're going to talk about pressure testing, perform leak checks, and perform flow and lockup. I apologize for the technical error. Here we go.
That PERC offered us. Just to remind you, trainings like that are available to NPGA members. So please keep that in mind. There's a lot of great information on there. So please utilize that. That was a great video that we watched that PERC offered us. Just to remind you, trainings like that are available to NPGA members. So please keep that in mind. There's a lot of great information on there. So please utilize that resource. They talked about pressure tests and did a great job of showing an example of how to pressure test piping. Now remember, pressure tests are required for new piping, or if you add piping to an existing system, that new section of piping needs to be pressure tested. Again, pressure test means, by definition of NFPA 54, you must test this piping system at 1.5 times maximum allowable working pressure, but not less than 3 psi. So if you're going to be delivering 3 psi into a piping system, make sure that the appliances are disconnected. All cook stoves, dryer, water heater, boiler, furnace, whatever, that's got to be disconnected per 54. So also keep in mind that your valves have to be rated to accept that kind of pressure. If they're not, the valves have to come off. You have to plug or cap the piping. So disconnect your appliances per code. You don't want to damage a gas valve on a brand new appliance by putting too much pressure to it. They use this pressure test gauge assembly that I have right here, and this is great. They threaded this directly onto the 3/4 inch stuff that was sticking out of the building. If in fact you've got a propane system that's only using copper tubing, you can just thread another adapter in there and use the same kit, just with an adapter on it. Keep in mind when you are doing pressure tests though, you want to keep your gauge at no more than 5 times the test pressure. So an acceptable gauge on a pressure test for a low pressure system will be up to 15 psi. This one right here I have is a 5-pound gauge, which is going to really give me a quick indication if there is a leak in the pressure test. So keep that in mind. The code also references the duration of the test, and that's based on the length of piping you have. If it's just a single dwelling, and that gas piping only requires about a 10-minute test. So keep those things in mind. If in fact your pressure test shows a leak, you need to make the repair and retest that whole system and document it. So the pressure test is very important, and it's very specific in NFPA 54. Don't forget, do not use gas. Do not use oxygen. You can use air with an actual, you saw in the video, they use the air tank to pressurize the system. You can use nitrogen or CO2, but do not use oxygen. So that was our pressure test portion. What we're gonna do next is talk about leak check. And what I have here are regulator boards, and this right here is mimicking the load or appliances in a customer's home. So we're gonna do a couple different types of leak checks. What I'm gonna start with is talk about our gas pressure. Propane pressure is directly affected by temperature. So today being 80 degrees, we know that the gas pressure inside of a propane tank is gonna be about 140 psi. So I'm gonna start with that. The reason I mention that, and it's so important, is when your technicians or drivers are filling out a leak check form, they must document if they do a test, whether it be pressure test, leak check, all of this stuff. There's even spots for flow and lockup, which we'll get to. Make sure it's documented and signed. So at 80 degrees Fahrenheit, we've got about 140 psi in a tank. If it were in fact 0 degrees Fahrenheit, there would be about 28 pounds of pressure in a tank. So make sure that they're doing this thoroughly and writing down the gauge readings that they're getting. Don't just make them up, because ultimately that can come back and bite them. So I'm going to turn our source on. I'm using nitrogen. We are in a building. So we're going to manipulate this and give our system 140 psi tank pressure. So we'll work its way up to 140 psi. The tests we're going to do are going to be through our first and second stage regulators. We could do the same test through our twin stage regulators. So we have 140 psi in our system, going through our first stage regulator, which takes our tank pressure and drops it down to 10 psi, to our second stage regulator, which takes the 10 pounds and drops it to 11 inches of water column, which we're just over 11 inches on the outlet of our second stage regulator. So now I'm going to introduce the gas to our system and up to our appliances. Opening valve slowly. We're going to show that we're a little bit over. We're right about 12 inches of water column on the outlet over at our appliances. So to perform our leak check, we're going to do first our high pressure one that's specified in NFPA 54. And this is at 8.2 of NFPA 54. So I'm going to shut our gas off as it says in code. Then what they want us to do is drop our tank pressure 10 psi. So we're at 140, I'm gonna drop that down to 140 through the bleeder of my Presso Tap gauge setup. We'll drop it down to 130 PSI, and the reason we're doing that, besides leak checking the system, we're also testing the integrity of the service valve of the propane tank. After 3 minutes, if we find that the gauge is increased in pressure, we know that the service valve is enclosing fully. After 3 minutes, we find that our tank pressure is less than the 130 PSI, we have a leak. Then it is our job to find that leak, repair it, and again, retest. So that's how we do very simple high pressure leak check. We'll do this right at the tank with a T-block, another number of different means to do that. Newer tanks nowadays do come with a test port in the service valve, which you could utilize to put a Presso Tap fitting into, or a serviceman's friend and attach your gauge to it. So it makes it very easy. You don't have to disconnect the pigtail and get the chance of any flaking of copper into your first stage regulator. So it's a very, very handy tool. So that's our high pressure leak check. We determined we have no leaks. Now we're gonna go in the basement, and for that matter, we could also do it at the outlet of our second stage regulator. Again, delivering 11 inches of water column. This one's up a little bit, almost 12. We can do it at the outlet of the second stage regulator or at our integral twin stage regulator. I'm going to do it using our water manometer. So I've shut the source off, pressurized the piping, shut the tank off, just as it says in 54. Then I'm going to drop some pressure. I'm going to create a leak, get the pressure in our system downstream of the second stage down to 9 inches of water column plus or minus a half an inch. Again, we're doing two tests. We're testing for leakage and we're testing for the integrity of the service valve. We're going to drop that down so that regulators are completely open. A little bit more. 9 inches of water column. So we're going to watch this for 3 minutes, or you can start your paperwork, come back in 3 minutes, and determine if we're still at 9 inches of water column. We have determined that the piping system is leak-free. And then we can turn our tank back on and light the appliances. Make sure you finish your paperwork, have it signed if you can. Have your technician or driver sign it so it's an official document. This right here is called a gas system check. And this has all the information you need about the customer's appliances, their home, their address, the tank, serial number, what size tank, whether you did a pressure test or not, and you can document what the starting pressure was, the ending pressure, etc. There's also spots in here to document what you have for regulators. It's important to put all the appliances that you have on this gas system check also. In the event that while you're not there, a homeowner or someone else comes in and installs another appliance, and then something catastrophic happens, knock on wood that it doesn't, but if something catastrophic happens, you're going to be in court and you can produce this document that says they had a water heater and furnace and that's it. There was no fireplace when we were there, and that may have been what caused the incident. So very important to do these tests, but as important is to document them. The next test we'd like to do is the flow. And really what the flow is, we're just trying to determine if in fact our system can provide the proper amount of pressure all the way to our appliances. So we're going to do that. We know what our pressure is at the second stage regulator and over at the appliance. And code says that we're going to introduce about half the full load of that system. So we're going to say there's a 350,000 BTU load on this system. So I'm going to open my 175,000 BTU load. There's an orifice in here that will replicate that. I'm going to open that. And I see that our system, the regulators and our piping is still delivering 11 inches of water column, which is very, very important. But while we're here, we can do a lockup test at the same time. So we've got a load going, we shut the source of gas off, and we realize that it doesn't lock up higher than UL 144 states. UL 144 states a second stage regulator must lock up or close bubble tight within 120% of the set pressure. So if this is set at 11 inches, our our lockup cannot exceed 13.2 inches of water column, which we're well within that range. Lockup, the term, is sometimes misunderstood, and I want to just explain it real quickly. This is a simple regulator. It's a cutaway regulator by Rego. But right now, this regulator is trying to deliver gas. The spring pressure has overcome the pressure underneath it. So while gas is flowing, the regulator is open. Once the appliance shuts off, this regulator is going to lock up or close bubble tight. The appliance is running. As soon as you shut it off, the pressure underneath the diaphragm overcomes the spring pressure, closing the regulator or locking it up. In this, while it's locked up, it will show that the seat disc presses against the orifice, closing this regulator. Again, they call it locking up bubble tight. So again, second stage regulator is required to lock up at 120% of set pressure at 10 pounds inlet. The first stage regulator is allowed to lock up at 130% of set pressure. So this should never lock up. If it's set at 10 psi, it should never lock up at more than 13 pounds. So that's really important. So we've determined, given our piping system we have here, our flow and lockup is really good. We're all within the parameters that we're looking for, per code and per UL listing. So now I'm going to manipulate it. Again, I'm going to install undersized piping. See how the regulator and the piping system react. To perform these tests, you can use your gauge that we have installed on our second stage regulator. You can use a digital manometer. It's a great tool. Our YouTube manometer, there's a number of different ways we can check. Now we've installed undersized piping. Let's see how the regulators and the system react to this. It is my recommendation that you do your lockup test at one of the furthest away appliances. And I'll explain to you why coming right up. Again, we've got an inches gauge installed on our second stage regulator, reading just over 11 inches of water column. I'm gonna bring the gas over here. We've got that there. So now with our undersized piping, remember that our flow with the proper size pipe was still flowing at 11 inches of water column. I'll open the same flow, 175,000 BTUs. And notice that we're just under 8 inches of water column. Not acceptable for most high efficiency appliances. Modulating gas valves are going to sense that low pressure, probably flash a code at you, and you'll get a no heat call, no hot water. So we're flowing not enough just because of our restriction in the piping. Our regulator still says it's delivering enough pressure. Watch what happens when it locks up. We're going to see a spike. You hit almost 14 inches of water column lockup. That is well beyond the limits allowed by code and by UL. I'm going to open our full load at 350,000 BTUs and see how the flow and lockup is then. Again, our second stage is delivering what we're supposed to, but we're now under 7 inches of water column flow. In our lockup, that hit 14 inches. So again, not at all acceptable. We can learn a lot just by doing our flow and lockup at the right place in the system. We've determined, even though this may have been buried in the walls, at some point they may have added too many appliances to the piping. There may be a kink or an obstruction of the piping. So this is why we do our lockup, especially downstream of our second stage regulator, down at the appliances. UL 144 also mentions something else which is very important to regulators. Any final stage regulator is required to have a relief valve. It doesn't have to be integral like these are in our Rego regulators. It can be installed downstream of the second stage regulator, but it's designed to protect our downstream piping and our appliances. The relief valve settings on these regulators are very specific. The first stage regulator, at 140% of set pressure, again, that's set at 10 pounds. So at 14 PSI, that has got to start relieving and protecting our downstream piping. Our second stage regulator gets a rating of up to 170% of setting. So for instance, if this was set for ease of math, if this was set at 10 inches of water column, at 17 inches of water column, this must start relieving. Again, all that is to do to protect our downstream piping, protect our appliances, and the people who are in the building, as well as yourselves. So that's just a short demonstration of how we perform leak checks, flow, and lockup.
Any questions, please don't hesitate to type them in the chat. We're here for you folks. This is also being recorded, and if you choose to share it with other employees, you can click on that and watch it again. Does anybody have any questions? And again, thank you all for joining us. Go right ahead, we'll be monitoring the chat. On the screen shows you Adam's email address as well as mine, as well as our cell phone numbers. We are technical trainers. We do training in the field, on job sites, at our branches, at our customers' locations. For immediate assistance, if your techs are in the field, or if you'd like to place an order or have a technical question, please call our hotline at 866-999-1075. Thank you again for coming, and we'll sit tight for any more chats if you're at all interested. Thank you. Thank you all again. Be safe out there.